Question number 13 from section 4.5 exponential logarithmic equations. We want to solve for x. Here we have a logarithmic equation, and typically you want to, when you solve a logarithmic equation, if you can get it in the form of one base, one argument, one exponent, then you can convert it to exponential form. However, we have actually two logarithms here, a log base 4 of x and a log base 4 of x minus 6. We're going to use this property of logarithms. When you have two logarithms with the same base that's split with a plus sign, you can condense it down to a single logarithm. That single logarithm is going to look like log base 4. They both have the same base, split with a plus sign. That means we're going to take the argument of the first logarithm and multiply by the argument of the second logarithm. And that's going to be x times x minus 6 equals 2. Now this is the same thing as log base 4 of x times x minus 6. If you distribute the x, you get x squared minus 6x. All of that equals 2. Now it's in the form of a single logarithm where you have a base. The base is 4. The argument r is all of this, and then the exponent t is 2. It's in the single logarithmic form, so we can convert to exponential form. The base is 4. The exponent is 2. That has to equal the argument x squared minus 6x. So essentially we took it in this form and converted to this form. Now we have this equation. It's a quadratic equation. We solve a quadratic by setting everything on one side equal to 0. We already know that 4 squared is equal to 16 equals x squared minus 6x. I'm going to subtract 16 from both sides of the equation. And I get 0 equals x squared minus 6x minus 16. I'm going to bring that up here so that we can continue solving this equation. 0 equals x squared minus 6x minus 16. Now we can solve a quadratic equation by using the quadratic formula. We could also sometimes factor if that's possible. This one, I believe it can be factored. The factors of negative 16 that add up to negative 6. The factors would be x minus 8 and x plus 2. Those are the two factors. You can check that those two factors indeed, when you use FOIL, will simplify to this. Now using the zero product property, set each factor equal to 0. If you set 8 minus x equal to 0, sorry, x minus 8 equals 0, you get x equals 8. If you set x plus 2 equal to 0, you get x equals negative 2. Now at first glance, it looks like we have two solutions, but you do need to be careful here. When you are evaluating logarithms, the r, the argument, must be positive. R must be positive. R has to be greater than 0. When you plug in this x equals 8, you do get the positive argument. But when x is equal to negative 2, you get we call it extraneous solution. This does not end up working out. You cannot have a negative argument. The argument must be positive. So this solution, although algebraically in the beginning it looks right, it doesn't check. So this is our only solution, is x equals 8. We're going to check our answer using 8 as our, check your answer. So you see that that is the only answer. We use the properties of logs to condense it, and we use this conversion equation. We have to solve the quadratic equation, and we got two answers. We can rule out x equals negative 2 because if you plug that in, you end up with an extraneous solution. Okay, let's look at question number 14. We want to solve the logarithmic equation, but as you can see, we have one logarithm on the left and one logarithm on the right, and we can't make this equation conversion unless we have a single logarithm. So what we're going to do is subtract this log x minus 4 from both sides. Now when you're subtracting logarithms, please be careful here. This is the same thing as log of 5x plus 9 minus log of x minus 4. You don't subtract the arguments. You write as two separate logs. So that is equal to 1. So by subtracting log of x minus 4 from both sides, we get this equation. We have a logarithm that's split with a minus sign. We can condense it using this property here, called the quotient property of logarithms. We can condense this to a single logarithm. It's going to be the logarithm of a quotient where the numerator is 5x plus 9, the denominator is x minus 4. Now we have a logarithmic equation that is in this form here. Log base b of r equals t. Now you don't see it, but there is a base here. Anytime you just see log without a base, we know automatically that the base is 10. That's the common logarithm. Now we can convert to exponential form. The base is 10. The exponent is 1. That has to equal the argument 5x plus 9 over x minus 4. We can solve this equation by cross multiplying. You have a fraction on the right, and 10 to the first you can write as a fraction on the left. When you have a fraction equal to a fraction, you can solve this by cross multiplying. We can say 10 times x minus 4 has to equal 1 times 5x plus 9. Let's do that over here so we have some room. 10 times x minus 4 equals 1 times 5x plus 9. Let's distribute the 10, and we get 10x minus 40 equals what we get when we distribute the 1, which is 5x plus 9. Now we have an equation that can be solved by using algebra. We can subtract 5x from both sides of the equation, and that gives us 5x minus 40 equals 9. Now we're going to add 40 to both sides, and we get 5x equals 49. We can divide by 5 on both sides to get x equals 49 over 5. Let's check our answer. Okay, so the strategy for solving this one is to subtract the log from both sides using the properties of logs to condense it into a single logarithm. Once you get a single logarithm, you can convert to exponential form and then use some algebra to simplify.